This is the warming so far, roughly 1 degree, and this is the so-called safe 2-degree level. Well, it doesn't appear very safe from a scientific perspective. Just one signal of how important it is that if we are targeting 2 degrees, that we are damn certain of not exceeding that level, because it's already a very dangerous level indeed. Now, the question that was posed by 30 or so leading global environmental change scientists 3 years back, Jim Hansen and Will Steffen among the co-authors in this work, was, do we now have to put the planet into the pot? Do we now have to consider the risk that we are threatening the stability of the planet's desired state, and that we may be coming to a point where we are undermining the ability of the planetary system, regions to the global scale, to support human development? And as you know, for example, Ban Ki-moon, the Secretary General of the UN, for climate is pointing out that this may in fact be the risk. He said clearly in the run-up to the COP15 in December 2009 that we have the foot on the accelerator, we're driving towards the abyss. Scientifically, we said, well, that may in fact, unfortunately, be the case, but science has a responsibility to also inform the world that we're assuming that we're driving on a straight, tarmac highway, when in fact nature is a meandering path full of potholes. And that science has a responsibility to turn on the light onto this engine that humanity is driving into the darkness. And by doing so, by identifying what are the Earth system processes that determine the stability of a desired state, and moreover, for those processes, what are the thresholds we want to avoid, and could we even find the control variables that define whether or not we're pushing ourselves too close to undesired thresholds, and could we even, by defining the threshold, place a boundary, a safe fence upstream of this threshold to create a safe operating space for humanity. So to say, to redefine a new conceptual framework for sustainable development in the Anthropocene. Now, what is then the desired state? Well, in fact, science has good basis to define the desired state for humanity. This is ice core data for the last 100,000 years on the planet, and showing on the y-axis temperature variability, a good proxy for the physical living conditions on the planet. It's an interesting period because it's roughly half the time that we've been fully modern human on the planet. So we've had the same ability, so to say, for wealth creation and development as today. This was a jumpy ride indeed. We left Africa in a very cold and thereby dry, water-scarce point 80,000 years back. And we reached Asia, as you know, already 50, 60,000 years back. And again, probably left for colonizing Europe under another drought-scarce period. And then we enter the extraordinarily stable Holocene phase. And just 1,000 years into this phenomenally stable stage, we invent agriculture, we domesticate animals and plants, and we start the civilizational travel journey that we all know so well. We reach 3 billion people at the cutting point for the human acceleration, and we're today 7 billion people committed to 9. We can, of course, go back to the variable point outside of the Holocene, but there's no scientific evidence that there's any other period in the planetary conditions other than the Holocene that can sustain in a responsible way a population of 9 billion people. So we determine this as the desired state for humanity. Now, the question then is, are we threatening this state? And asking this question to this group of global change scientists, they came up in an analysis that was published in Nature in September 2009 with a proposition that there are 9 major processes that are of relevance in order to ensure the stability in the Holocene. Now, the interesting with this set of 9 planetary boundary processes is, first and foremost, that it's not only climate. This analysis shows that climate is but one, as Martin Lees pointed out earlier, among many interactive, large-scale processes that determine the ability for us to secure human development in an era of global change. Climate change is, of course, one of them, but it's coupled in this analysis with 2 other systems which have evidence of large-scale thresholds that can profoundly threaten the desired state of the Holocene. The first one is stratospheric ozone depletion, and the second one is the risk of large-scale thresholds in the oceans. And we defined here ocean acidification as the key process to be, so to say, focusing on. But we also, and perhaps surprisingly, defined 4 processes that are what we call slow variables, which determine the underlying resilience of the planet to be able to cope with large-scale disturbances. So the large processes or the large systems that determine the strength of the planet, including the large nutrient cycles of nitrogen and phosphorus, rate of biodiversity loss, land use change, and freshwater use. The systems that determine the ability from landscapes to regional systems to control rainfall, to control delivery of carbon, delivery of food and biomass, and also the ability to withstand shocks. And then this analysis also identified chemical pollution and aerosol loading, which is air pollution at large, as two factors that we also need to consider as processes that are candidates as planetary boundaries. Now, these factors interact in real time, and I'll give a couple of examples of that. And most science indicates, as a working hypothesis, that they have a Three Musketeers behavior, one for all for one, in terms of securing human development, i.e., that we need to stay within the safe operating space for all of these in order to enable long-term development. Now, I'll give a couple of examples how we reasoned here, and what you see from this graph is that we attempted to even quantify 7 of them, of which some of them have very solid scientific evidence, such as climate change and ozone depletion, while others are very tentative, like on freshwater use, land use change, and nitrogen, phosphorus, and biodiversity loss. And this was published in Nature and gives us the ability also to do something very interesting in terms of guiding humanity in the global phase of sustainability. Namely, in green here, you have then the tentative identification of the safe operating space in terms of quantifying the boundary levels for these 9. And what data shows is that we may have transgressed already 3 of these on climate change, and the evidence is starting to be clear, such as the tipping point in the Arctic, rate of biodiversity loss, and the interference with the nitrogen cycle, where humanity today takes out more nitrogen from the atmosphere and plugs into the biosphere than the whole natural cycle in itself.